What the hell is actually dew point temperature and why do we care? I just did a story with Popular Science on this. Dew point temperature is actually the temperature that if you cooled the air down to, it would become saturated. So basically, how cold do you need to make the air around you in order for it to turn into a cloud? If you know how to use it, it is a great humidity indicator, but it actually is a really, really important recipe and thing that we need to know when doing severe storm forecasting. You see, between all the little air molecules floating around in the sky, the warmer the air is, the bigger the gaps between those molecules, the less dense the air is. And the colder it is, the more dense that air is and the less room there are for those little water vapor molecules. Remember, water vapor molecules are the gas form of water. You can't see it. It's invisible. It's around us all the time. Dew point temperatures in the 60s feel pretty unpleasant. Once they reach the 70s, things start to get oppressive. But here's where things get interesting. Dry air cools at about 5 degrees Fahrenheit for every 1,000 feet you go up in the atmosphere. The second you have water present in that air, meaning you have saturated air that it turns into a cloud, that changes. Now it's going to start cooling at a rate somewhere between 2 and 5 degrees. So it's going to cool a lot slower as you go up in the atmosphere than the dry air. This creates a phenomenal thermodynamic imbalance in our atmosphere. So once you go up, say 10,000 feet, that cloud is going to be a lot warmer than the air around it. So what is that cloud going to do? It's going to continue to rise, and it's going to rise fast. We can take a look at this through weather balloons and the data that they plot, which is this QT diagram right here. So what we can do is take a look at this little point right here and say, oh, this is the temperature where this air at the ground, it's going to rise and cool. It's going to reach its dew point temperature, which means it's going to turn into a cloud. And then we know it's going to follow this profile once it has condensed, once it has become a cloud. That is different than the air around it. It's going to keep it rising. This gap right here is CAPE. It's called convective available potential energy. And it tells us the amount of energy in the atmosphere and how much faster that cloud's going to rise than the area around it. That creates low pressure at the surface. And this is a key ingredient in severe storm forecasting. It's also worth mentioning with all the NOAA budget cuts that are happening, a lot of National Weather Service offices are having to cut back on the radiosonde launches. And this is a detrimental thing during severe storm season where sometimes these offices would do 3 launches a day to try to understand the profile of this atmosphere to better forecast severe storms. But a lot of offices now aren't releasing weather balloons or only doing them once a day. This is going to be really, really bad for severe storm forecasting. These little red and orange dots show you all the places where we have reduced radiosonde soundings due to those NOAA budget cuts. These are places where we have reduced information on severe weather forecasting. So for more details, go to Popular Science or click the link in my bio to read all about why dew point temperature is so darn interesting. Be sure to like, follow, and subscribe. You can find me at WX Serena on all social media and on the Stormfront Freaks Network.